Yes, 3x minus 1 times x, which indeed is 3x squared minus x. Perfect. Minus?
Then it'd be x squared.
It's better to write it like this first.
Oh, okay, yeah.
Because
Yeah.
we need, after we square, we need to distribute this. The negative 1, which we know is there. Good. So as you said, perfect math, 3x squared minus x minus, let's square first using the special product and then distribute negative 1.
X squared minus 4x minus, or sorry, plus 4.
Plus 4. The last term is always positive no matter what we have inside. Good. Now I will distribute carefully. So I have 3x squared minus x squared plus 4x and minus 4, because we need to distribute it to all three terms. So the final form will be 2x squared plus 3x and minus 4. What is this expression? It's the expression of all the shaded area in here. So this piece is 2x squared plus 3x minus 4. So is everyone able to open those files that I send you? Okay, perfect.
Yes.
If something is wrong and you cannot, they are posted in the top module in Canvas. Okay, so there is nothing else I have to say here. So we are moving on to something called scientific notation. This is basically a review from arithmetic. So I'm just going to go directly to practice. But before we even look at the practice, I just want to discuss it. First of all, what is the exponential notation? Not the scientific notation. And what is it used for? Why do we need it? La, la, la. So this is section 5.6, scientific notation. And you will see why it's here. And then we'll look at division of polynomials. And that's the end of mods 5. Okay, so 5.6, scientific notation. Okay. The scientific notation is a number which cannot be 0, not 0. The decimal point, whatever, times a power of 10. The power of 10 can be positive or negative. This is what we call scientific notation. A number that cannot be 0, anything from 1 through 9, 1 through 9, but not 0. Whatever follows, just one digit, the decimal point, whatever, as many digits as needed, multiplied by a power of 10, meaning this power here can be a positive number or a negative number.
Yes.
That's what we call scientific notation. How does it appear in the graphing calculator, which is important? In the graphing calculator, can appear like this: 2.3 e to a negative 10. What is all this? It means 2.3 times the power of 10 with a negative exponent of negative 10. So this means 2.3 times 10 to negative 10. What if it, say it again?
That's what I said, it means it's a decimal.
Here is a decimal point, yes.
No, I mean with the negative exponent. I mean when you put it out, you're going to go to the left.
I was going to go to the left, correct. I was going to explain that, yes. Perfect. So another one could be 1.99 E2. This means 1.99 times 10 to a positive power, which is 2. So this is important to understand when you see something like this as an answer in the graphing calculator, to understand what it means. So let me show you in the graphing calculator. Good. Here it is. So let's say I want to divide 1 by, I'm just putting some numbers in there. Here it is. So the answer is a very small number, meaning 4.239 times 10 to negative 7. Okay, so this is how it appears. If the number that is that follows E is positive, then it means it's 10 to that positive number instead of 10 to negative 7 in this case. Okay, now let's suppose I'm given the following number, 0.00392. And they're asking us to change it into the scientific notation. Scientific notation requires a non-zero digit, 1 digit, decimal point, the rest, and the power of 10. So then it means that I have to move the decimal point exactly 3 spots to the right. So then this is 3.92, but I have to come up with a power of 10, and the power of 10, because it's a small number, it has to be negative. So 3.92, I move the 3 spots to the right. That's why this power is negative 3. Another example, 0.000000394. I'm asked to change this into scientific notation. I have to move the decimal point 1, 2, 3, 4, 5, 6, 7. So I have 3.94. Since it's a tiny number, the power of 7 has to be a negative number. Okay, now, what if I have a huge number, like 2, 3, 9, 4, 0, 0, 0, 0, 0, 0, 0. I don't see the decimal point. Of course, it's right here. If there is no decimal part, the decimal point follows the last digit. I am asked to change this into a scientific notation. So I have to move the decimal point right after the first non-zero number. So this would be 2.394. Because it's a huge number, the power of 10 must be positive. But what is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is basically all about scientific notation. If the number is tiny, please remember the power of 10 will be negative. If the number is huge, please remember the power of 10 must be positive. Very good. So let's practice with this. 5.6, practice scientific notation. So let's start. Write 4 in scientific notation. Really? My goodness. Okay. So 4 in scientific notation is 4.0 times 10 to 0 power. It cannot be positive, it cannot be negative. It's a little silly to start with that, but it is what it is. Okay, now we're talking. 103, comma, 0, 0, 0, comma, 0, 0, 0, comma, 0, 0, 0, comma, 0, 0, 0. So changing this into scientific notation, obviously, I have to have 1.03. It's a huge number, so the power of 10 has to be a positive number. But I have to count. 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, 13, 14. So power 14. If I want to put this in the graphing calculator, how on earth will I do it? Here it is. 1.03 times, it's EE, this comma, second, am I sharing? Yes, I'm sharing. Okay, so second and comma is the EE, and you put 14. That's how you enter it. I'm wondering if I press enter, what's going to happen? It's not going to do anything. So 1.03 times 10 to the 14th. What if I want 1.03 EE negative 4? Let's see if it changes or does anything. Maybe not. No, it doesn't. So this means 1.03 times 10 to negative 4. But this is how you enter it in case you have to. Maybe you want to multiply it by something, or maybe you need to divide it by something. You need to know how to enter it in the calculator. Okay, the same thing here. Yes?
If you were to use that, would you have to put it in parentheses?
It depends if you're multiplying it by a negative number. So you are going to say, so let me go to the previous entry. And if I need to multiply it by, let's say, negative 5.2, then you will have to put that in parentheses.
Okay.
Because if you don't, it will consider it an addition or subtraction instead of multiplication. So it calculates, and it gives us still the scientific notation, negative 5.356, la la la, times 10 to negative 4. Very good question. Okay, I don't think we have any difficulties with this.
Question. So
Yes.
the E in the calculator just means times 10 to the power of
Yes,
whatever.
yes, that is the EE. Yes,
Perfect.
yeah,
Thank you.
thank you. Good. So let's write this one in scientific notation, 0 point. I think I counted 4 zeros. Good. So what do we have here? Of course, we have 3.4 times 10 to which power?
Negative 5.
Yes, indeed, negative 5. It's a small number. The power has to be negative. Good. Again, the same thing. Write this number in decimal notation. Okay, now going backwards, basically. So we are given 9.3. Because the power is positive, I have to get a big number. I have to move the decimal point 5 spots to the right. So 9, 3, that's 1 already. 1, 2, 3, 4. So I move the decimal point 5 spots to the right. So after 3, after a 0, a 0, a 0, and a 0. 1, 2, 3, 4, 5, because that's the power. Is that okay? Okay. Now the 2 times 10 to negative 6. Now do not confuse this x. This is not x. It's the multiplication sign. It should not be that. They should use the raised dot, not this. But they are using it, so be aware of that. Good. So now the decimal point, which is here after 2, has to be moved to the left 6 spots. Why? Because this number is very small. Since it is right here, I have to move it 6 to the left. 1, 2, 3, 4, 5, 6, and put the decimal point in front of it. So make sure we have 1, 2, 3, 4, 5, 6, and it goes back right after 2. So if it's a small number, we move the decimal digit to the left. If it's a large number, we move the decimal digit to the right, based on the number that is the power of 10. That's the number of spots we go, either right or left. Good. Okay, the same thing here. I just want to get to some operations. We know how to do this. Please stop me if you want me to work on. So there were coffee drinkers, write the number of coffee drinkers in standard notation, okay? Meaning we have to move the decimal point 6 spots to the right, because 10 has a positive power. Write the calculator answer in the correct mathematical form of scientific notation, indicate. Okay, so this is, let's write it. 5e and negative 16. 5e and negative 16 means 5 times 10 to negative 16, which means we have to move the decimal point to the left because the number is very small, 16 spots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, and put it in front of it. So these have to be 16 digits. Any questions? Any questions? Any questions? Okay. Okay, the same thing, just in the opposite direction because the power of 10 is positive. Same thing. Same thing. Okay, so now this is something different. Which is larger? This is important to work on. Now, power negative with power positive, there is no discussion which one is larger. Because here I have to move the decimal point 4 to the left, and here I have to move the decimal point 2 to the right. So there is no discussion there. Which one is larger? The one with negative 4 as the power or the one with 2?
2.
Of course. So there is no discussion there. Now, power 2 and power 4. So this is 980, and this one is 85000. So obviously, which one is larger? Yes. Good. Let's look at the last one. Now here we have to be careful because these are decimal digits, with a negative power, right? So negative 4 will go to the left 4 units, 4 spots. But negative 6 will go to the left 6 spots. So which one will be larger? The negative 4 will be larger. Yes, indeed. Good. Standard notation, I don't think we have any difficulties with filling in that table. The same thing here. Okay, so they just want us to type it in. So this will be 0.5044. 0.1234 544. So there's 6 digits, 2, 4, 6. Okay, so let's see what else. I just want to see if we have any operations. Multiplication. Ah, yes, that's what I was looking for. Okay, so 2.4 times 10 to the 7th everything multiplied by 2 times 10 to negative 3. Okay, this is what I was trying to get to. So we have to carefully look at between 20 and 31. Okay, so first of all, we have